So let's take a look here at how we factor trinomials. Now, for trinomials, T-R-I, that means 3, right? Like tricycle or try something or other. Try Wizard Tournament, there you go. So try means 3. So whenever we're doing this, we can only do these kind of strategies if you have something that has 3 terms. So like x squared plus, say, 7x plus 10 would be an example of a trinomial. You have 1, 2, 3. If it said, plus xy, then it's not a trinomial anymore. Okay? So there we go. So whenever we're factoring trinomials specifically, we're looking for a particular pattern. All right, and that particular pattern right now is going to be something squared and that same thing in the middle, and then something else on the end. But again, the whole idea is you've got something squared, that same thing appearing again, and then something on the end. So really, all kinds of things would work. Tell I'm getting my car fixed. Again, you have the same idea. Something squared, something in the middle, something squared, something in the middle. And it doesn't have to be x, it could be this. Okay, so these all count, even if it's in a weird order, we can always reorder it. But again, as long as you have something squared and then something in the middle. If I reorder it, I'll have something squared and something in the middle. So we're going to be looking at solving things like this. What we're not going to be looking at are things like this. I'm trying to think of a good example without messing it up, without accidentally giving you a good one. But in general, we're not looking for things that have, okay, like this. Because this is cubed, and this is the same thing in the middle, but it's cubed, not squared. Okay, so something like that wouldn't count. So we talk about factoring trinomials, we're really looking for things that follow a specific pattern. Okay, and there's actually ways that we can vary on this pattern, but it's still going to match the pattern. We'll talk about that in a bit. So to talk about how to factor things, remember how to FOIL things. It's important. So I'm going to assume going forward that you're pretty familiar with this, so I'm just going to kind of assume this is a review. If it's not, no problem. There's other resources for you to get that too. So if I want to FOIL this, remember, I want to look at this and I want to say first, outer, inner, last, right? FOIL method. So x times x is x squared. Outer, 2x. Inner, 5x. And last is going to be 10. And I recognize that I can combine like terms, 7x plus 10, like that. Good? But the question is, well, what if I started out with this and I wanted to get the things that it multiplies to make? So when we factor, we should only have things that are multiplied together. So the last thing you should do is multiply. Okay, so the way to do this is like solving puzzles. I wish I could give you like an algorithm, like, oh, you always do this, and it always turns out, and it's always beautiful. Sometimes it is, but sometimes it's not, and sometimes it takes longer than it takes at other times. So when I'm looking at this, I say, okay, if you look at this example here, you can see this is the term I get from the first, and this is the term that I get from the last, and this is the term that I get from the oi, right? From the outer and the inner. Okay, so what I want to know is, okay, well, first, what can I multiply to get x squared? There's pretty much only one option, right? I can get x and x. That's the only way I can get x squared, is if both of those are x and x. Okay, but what are the different ways that I can get a 10? Well, I can get a 10 by multiplying 1 times 10, or I can multiply 2 times 5. Okay? So the idea is that you make that observation, and then you decide which factor to use based on what you have in the middle. Okay? The other thing that we have to decide is what our signs here are going to be. Are they going to be pluses, or are they going to be minuses? And so we say, okay, well, what's the only way I can have a plus 10? The only way I can have a plus 10 is, say I was using 2 and 5. I can have plus 2 times plus 5, or minus 2 times minus 5. This, or I could have this. But if one of them were going to be negative, then my last term would be minus 10, and it's not, it's a plus. Okay, so what you need to do is you need to make a decision about the signs in your factor and say, okay, well, if this is positive, then that means both of these signs here have to be the same. They either both have to be positive, or they both have to be negative. Oh, I'm sorry, that didn't make any sense. Or they both have to be negative, because if they're opposite of each other, if one's positive and one's negative, then I'll get a minus 10. I don't want a minus 10, I want a plus 10. So the way I make that decision is I come over here and I look here. Say, well, I need this to be a plus 7. The only way that's going to be plus 7 is if I'm adding the OI terms. If I'm subtracting the OI terms, and that'll give me a minus 7, okay? So it's kind of like you got to reason through it every single time. The more you do it, the better you get at it. But when you first get started, it's going to take some extra steps getting good at it. All right, so long story short, too late. This is a plus, so that means both of these have to be the same. And since this is a plus, that means they both have to be plus. Okay. Now I said I have two options. These can either both be 10 and 1, or they can both be 2 and 5. Okay? Now, you might look and say, oh, I know it's 2 and 5 because it's right up here. Or you just might be awesome. In which case, I'm going to just go ahead and show you both. So what happens if I put 1 and 10? Now, first of all, no, it doesn't matter whether I do 10 and 1 or 1 and 10. Those are going to come out to be the same thing, right? Because I feel like I keep erasing. 10 and 1 is the same thing as 1 and 10. For the same reason that 3 times 2 is the same thing as 2 times 3. So it doesn't matter right now because they're basically symmetric, what order I put them in. So now if I do this, I know my first term is going to be right, and I know my last term is going to be right, but let's check the inner and the outer. It's going to be plus x plus 10x. So that's going to give me 11x, and that's not right. I don't want 11x, I want 7. So ideally you'd like to look at that immediately and say, that's going to give me what I want. So I'm going to call that 2 and 5. And the great thing about factoring is you can always check your work. First, outer, inner, oops, x, inner, let's try this one more time, inner, last, and that's x squared plus 7x plus 10. Okay, so it's all a question about how you look at it and just kind of puzzling through it until you get the pattern, until you get kind of the jive of what you're doing. Okay. Let's try a similar example, pretty much the exact same thing, except I'm going to make that a minus 7x. Okay. Now again, in this case, I know the only way to get x squared is to multiply x times x. Alright. Now I want to look at the sign. Since this is a positive, that means they're either going to both be positive or both be negative. Right? It's the only way to get a plus 10 is they both have to be positive or they both have to be negative. But since this is a negative 7, that means that both of them have to be negative. Now, the only ways I can get a 10 is a 1 and a 10 or a 2 and a 5. So I can compare and say, okay, well, clearly if I go minus 1 minus 10, that's going to give me minus 11, which isn't what I want. So let's try doing minus 2 and minus 5. So I'll say, okay, I'll check it. X squared, well, that should be right automatically. Outer, inner, and last. X squared minus 7x plus 10. And that works. So that's good. Now, just to prove it, let's go ahead and do this. X minus 5 times x minus 2. So let's just make sure we get the same thing in a different order, just in case it's not painfully obvious, and that's okay if it's not. X times x is x squared. F, outer, inner, last. See, we get the exact same thing if we do it in a different order. So we're okay there. As long as the terms are exactly the same, if we do it in a different order, we'll end up okay. Okay? Alright. So let's try another example. Let's try x squared minus, let's say plus 9x, and now I'm going to put in a minus 10. And I know I want these to look something like this. Again, start from the front and work to the end, and if that doesn't work, start from the end and work to the front. The only way to get to x is x times x. So I can go ahead and plug those in. There's no options. There's no thinking about it. Okay. Now, to get the minus sign, I have to use a plus and I have to use a minus. It's the only way to get a negative 10 is to multiply a positive number by a negative number. So when I come in here, plus, minus, like that. Okay? Plus and minus. All right, now here comes the tricky part. The different ways to get a 10 is a 1 and a 10 or a 2 and a 5. So what you can think about is, okay, well when I outer inner this, I'm going to be adding one of these, and I'm going to be, well, subtracting that one, and I'm going to be adding this one. So really, until you kind of start to see, the best option is really just to plug it in and see what works. Okay, so if I put in a 1 here and a 10 here, right? If I multiply it out, I already know my first and last is going to be right because I specifically designed it that way. So really all I need to check is outer and inner. Outer, inner, and you see that gives me minus 9x. What did I want? I want it positive. So that means the number is right. It just means that my sign is backwards. So if the number is right and the sign is wrong, all you have to do is come in here and fix the signs. Now, so I didn't change anything. I just changed the positive to a negative and a negative to a positive. I just switched the signs because the number was right, just the sign is wrong. So now if I do this, I get 10x minus x, and that gives me 9x, which is exactly what I want. So I know I did that right. Okay, so you'll kind of go through this process over and over and over again until you, this is terrible to say, you just have to do it a lot until it starts to make sense. And you'll, as you do it more and more often, you'll start to sense patterns and see the kinds of numbers that we use over and over again. And then eventually you'll start to really find success with this.